Anyone? What comes to mind when you hear a statement?
Basically, it's something telling you what's happening.
Something telling you what's happening, right? Good. Now, Shane, what comes to mind when you hear a statement?
Can you repeat?
What comes to mind when you hear the word statement?
Statement?
Yeah.
A comment that was made.
Comment, okay.
Maths.
With maths. All right, good. Jamelia, what comes to mind?
A question written in like mathematical form.
Okay, question written. Dushan, what say you? Dushan? Statement mathematical what? Question. All right, guys. All right, so we said equations are, thank you all for your comments. So we say equations are mathematical statements, right? So a statement, as you know, says something. A statement is saying something about something, all right? It shows equality. Can anybody tell me what equality means here? Teresa? Trisha? Trisha? Shane? Jamelia? Dushan? What does equality mean?
Same.
Equal.
Same. Oh, equal. Same. Excellent. So let us dig in here. So we say an equation is a mathematical statement that shows equality between two or more variables. All right. Now, the deal here is when we hear variables, the word vary. What does vary says to us? Vary.
Very, very, very.
No man, you can't use the same word but tell me the same thing. What vary mean? When we say
establish
what?
It ranges from a certain number to something.
Okay, range. So it doesn't have a fixed, right?
Yes,
so the value of the something is not fixed. For example, if you walk from where you sit now to your door, you would walk a certain distance, right? But then if you walk from where you're sitting to the outside, the distance would change. Isn't that so?
Yes, sir.
Yes. So we could say that the distance varied, don't? People? Could we say that the distance varied? Yeah. So the variables in this case is referring to something that changes. And in this case, distance is an example of a variable. It is something, some factor that can change. All right? What about cost? Is everything the same cost that you buy?
No.
No.
No, sir.
So we could say that cost vary, don't?
Yes, sir.
And in this case, the variable will be cost. Am I clear?
Yes, sir.
Weight. Do all of us have the same weight?
No.
No. So we could say that weight varies, don't? And as a result, the variable here would be weight. Okay? Amount, same story. Shane just said height. And amongst many other things, right? So we're saying here that variables are things that change. So in essence, we say an equations are mathematical statements. So some statement using mathematics. I want some bright person tell me about when it's a mathematical. We're thinking of the statement to make it mathematical. Numbers. What else?
Signs.
Signs such as what?
Addition, subtraction,
subtraction, multiplication, division. Excellent.
And division.
All right. So these are the things that makes it mathematical, don't?
Yes, sir.
So we're saying an equation is some statement telling you about something that have addition, subtraction, multiplication, or division, or a
Division.
combination of these operations that shows how one variable is equal to the other mathematically. Okay, guys? Now, in math, we don't use words in equation. Anybody tell me what we use to represent the variables in an equation instead of the words? Davey?
X.
X? X?
X.
Is it just X?
Hey, letters.
Letters.
That's it. We use
Letters.
letters in general. Any letter in the 26-letter alphabet. Am I clear?
Yes, sir.
So, let us begin. Our first task right here is where we write an equation to show the relationship first task. Are you ready for me? Alright, now, before I said to you that equations come from something, what did I say they come from?
You're talking low.
Sorry, I said to you before that equations come from something. Where them come from? What do equations come from? You write it on the board, man.
Patterns.
Patterns.
So say equations come from patterns. Anybody know what patterns mean? When I hear pattern, what comes to mind? Anybody?
A certain sequence of numbers.
20. Okay. Anybody else? What else come to mind? Xavier, Trisha, Sean.
When I hear pattern, I think of something that I have to follow, something that goes in a specific order.
Something that goes in order. Okay. RCT, what's your name? Person here with the what's that color? Orange with the flowers on the background. RCT 656S03W12.
Yes,
What's your name again?
Taylor Francis.
Say again?
Francis.
Francis? Okay. What's your name? Keep it there. All right, Francis? No. All right, Francis, when you hear pattern, what comes to mind? What comes to mind, Francis?
Sequence, a specific sequence.
Specific what?
Sequence.
A specific sequence. All right. So I'll give you guys my definition of a pattern. A pattern is anything that repeats itself. Let's just say anything that does what? Repeat itself is a pattern. So you see something over and over again, that forms a pattern. Am I clear? Am I clear, guys? Okay, good.
Yes.
Now let's take it off now. No. We said equation shows equality, which means every equation must begin with an equal sign. All right? So equations start with an equal sign. Look like that.
Right.
Now, it says write an equation to show the relationship between cost and weight. Okay. Now, in math, we don't use the word cost and we don't use the word weight. Okay? We use letters to represent these two things. And remember, cost and weight are called variables. Am I clear?
Yes, sir.
And what the equation is trying to do is to show how one variable is mathematically equal to the other. Am I clear? based on the pattern that is shown. Okay? So let's go. Now, let us use C for cost, and we'll use W for weight.
For weight.
All right, great. Now it says equality between 2 or more variables. How many variables in this question?
2.
2. So then, as we said, we start with an equal sign, and then we put one variable on the left and one variable on the
Right.
right. Now, before we move any further, we're going to learn how to read an equation. Now, this statement right here, so right now, says C is equal to W. Is that so?
Yeah.
But at this stage, you need to learn what the equal sign means. The equal means same as. So put that in for me. Equal means same as. So anytime I say the equal sign, it means the same as. Everybody clear?
Yes.
This sign is called the equal sign, but it means same as. So therefore, this statement reads, and I quote,
C is the same as W.
not necessarily. It reads, but good try. It reads, the value of C is the same as the value of.
Equal to the value of W.
Don't say equal, Shane. It means same.
Same as.
So let's read it together, everybody. The value of C.
The value of C.
Value of C
is the
is
same,
the same
as
as
the value of W. All right? All right. Now let us look at the data we have right here. So, is the value of C the same as the value of W?
No.
No. All right. So for everybody, we look at it. It's not the same, don't?
Yeah.
So now our next step is to say, well, this is not true. This statement does not reflect what is in our data here. So our next step then is to ask ourselves, what can you do mathematically to cost to get weight? Anybody can tell me? And it must work. It must work for everything. Multiply what? Multiply what?
By itself.
The cost by 10.
You mean multiply the cost by what?
10.
By 10?
Yes.
Okay. So someone said multiply. So someone said multiply C by 10. Is that Francis?
10.
Okay. Let's try. Let's read this together, everybody. Everybody tell me, what does multiplication mean? Anybody know what this sign means? It is called the multiplication sign. But does anyone know what it means? No. Okay.
To multiply.
No, my dear. But what does it mean to multiply?
Times.
Times? No, sir. It means set
Up.
off.
Set off.
All right. Bright people are come back now. So let's read this together right now. Let's read this together, everybody. Come here. 10. Talk to me now. 10.
10. 10 sets.
Of what?
C
No.
is the same as.
No. What we said this read mean? What we said this say? The value
of C.
So let's read again. 10
10
sets
10
of
sets
of
the value of C is the same as
the value
of W. In other words, people, that is saying to you,
is the same as the value of W.
10 of this value, give you this.
Is that, yeah.
10 of this value, give you this.
With that.
10 of this, give you this. Is that true?
Yeah.
Is that true, everyone? Talk to me now, people. Talk to me
Yes,
now,
sir.
people. Yes. Look and see. Yes. All right. So we say now the equation has to work for every single thing. Otherwise, it is not the equation that represents the relationship. All right? So the next thing I said to you is that equations show relationship. And we know a relationship means what one thing have in common with the other. Are we clear?
Hold on.
And this
Similarities.
And the relationship is that all of them multiply by 10.
Right. 10 times the value of C will give you the value of the weight.
C equals the same.
All right. Now, next step. We can write two equations from this. Now we could write, what can we do to weight to get cost? Somebody figure it out and then tell me. What can you do to weight? Divide by what?
Divided by.
Divided by what? Come on, talk to me. What do we do? What do we do to get to cost? If we say weight is the same as 10 cost, how we get one cost?
Times what? 10.
What do you do to weight to get this value yourself?
Divided by 10.
Ah, everybody else see that?
Yeah.
So we divide this by
10.
10.
So once we divide weight by 10, we get the cost. Are you guys clear?
Yep.
Cost.
Yep, clear, crystal clear.
Yes.
Xavier,
Yeah.
Francis, Trisha,
Sir?
you're clear? Are you clear?
You can go ahead.
That doesn't let me hear yes, I'm in a hear no, but me does hear go ahead. Shane? Shane, you good? Shane?
Yes, sir.
Yes, sir.
Well, basically what you're doing here is trying to.
I'm listening.
No, I want you to finish.
You want me to finish?
Mm-hmm.
I'm writing the equation. I'm showing the relationship, the mathematical relationship between one variable and the other.
Okay.
All right? And this is called an equation. Okay?
Okay.
So when you do your profit and loss, and you see, can somebody tell me the formula to find profit? Anybody remember the equation to find profit? No?
Yes.
What is it?
What's that? Sale. I remember.
Anybody remember any equation at all? Give me something.
Simple interest.
What is the equation?
P times R times T.
Times?
P times R times T divided by.
Divided by?
100.
Equal to what? What does that give you?
The simple interest.
Interest.
Yeah.
What is that? It's sales price minus cost price.
Everybody see this equation? So this equation here is showing you the relationship between interest, profit, rate, time. What is that?
Yeah.
So what this shows is how interest is related to time, rate, profit. Cool?
Mm-hmm.
All right. So let's move it on. Take a minute and absorb this, guys. Take a minute and absorb it. What I am showing you tonight is how they derive this simple interest formula. They had to look at a pattern, and from that pattern, they realized, say, oi, but any simple interest me I find in the size, me just have to do this. No matter what me I do, me just have to do that. You guys clear?
Mm-hmm.
All right. I'm going to give you a question now. And here goes. The question is, there's a question. If weight is 1,000 pounds, what is the cost? Work that out and tell me how you get the answer.
100.
Box. Try to play bright.
100.
We're not hearing.
I heard one person.
100.
Persons.
100.
Persons.
100.
4 persons. Shane Deshaun. Trisha.
Come in answer already.
100.
100. I mean, you're 7 by 6 enough.
Me answer that long time. No?
You guys realize, once you have the established relationship, the equation, all you have to do is substitute what you have in the equation to get the unknown value. Everybody good?
Yeah.
All right, here goes a question for you to try by yourself. I will not interject until you're done. I have so many questions here. Okay, I'm going to erase. I'm going to clear the board. You guys are copying the question while I'm writing. That's the first question for everybody. You have just about 5 minutes to answer these questions. Go, go, go. I know the time to do this. I don't have to put the name. So let's go ahead without leaving. Then approach ya. Man, treat you like man them supposed to. 2 minutes ago, people. One minute to go. 1 minute. All right, guys, I'm ready. I'm going to begin one by one in the order I'm seeing you. Xavier, I won't tell you if you're correct. Everyone will allow them to get a chance to speak. And then we'll discuss the answer together. Xavier.
I'm not sure.
Xavier?
I'm not sure. I'm not sure.
Not
Honestly,
sure? What do you have in
no.
your mind? What's in your mind?
I'm not even sure. Not even sure.
Not
Honestly,
sure. Okay.
no.
Trisha? Oh, Trisha.
Sir?
Yep. What do you have in your mind?
I'm not finished.
Number one, the first question. Not finished?
No, sir.
Shane?
Sir, we're not finished yet.
Not even the first question. Francis?
I'm not finished.
Oh, Lord.
Sir,
Yeah. Jamila?
for the first part,
Uh-huh.
relationship between distance
Mm-hmm.
and time
Mm-hmm.
is two.
It's two what?
Two.
Two what, Jamila? Learning process. Don't beat up yourselves. This is the first you guys are seeing this.
2 centimeters.
2 centimeters. That's your equation. Try again. Remember, you're showing the relationship
Sir,
between
it's
one.
not clear to me, no, sir.
Not clear to you yet. Okay. Okay, it's okay. We'll get it.
Oh, sir.
I just know that is 2. I don't know
Something
2.
with two. Something with two.
And
Alright.
for the distance and the whole size, it's 2.
What?
The relationship between the distance and the whole size.
Uh-huh.
4. That's all I
It's
know.
4. Alright, you're on the right track. You're on the right track. Ashandre, what's in your mind? Ashandre? Nothing? Alright, let's go, everybody. Please pay attention. Pay here attention so we can get it the second time around. This is the second time in your life you're going to write an equation. So don't beat up on yourself. Let's roll. Now, the instructions say write an equation to show the relationship between distance and whole and time. So that is one equation. And another equation to show the relationship between distance and whole size. Now, what do we say equations start with again?
Equal.
Equal sign. Make sure everybody is paying attention, you know.
Equals that.
Equal sign. And then, what are the variables in the equation?
Because like the distance, the time,
Distance and time. So we're going to use D. We put anyone on the left and
D
anyone
and
on the
T.
right. So we use capital T for D and common T for distance. Is that all right? Xavier, are you seeing?
Yeah.
Okay. So these are our variables, one on the left, one on the right. Now, let's read this together, people. What does this mean? What is this reading?
The D is for distance and the T is for time, right?
D equal T.
No, that's not what it means. It means something else.
Distance equal to time.
No. The value of distance
Distance
is the
same as the value of
time. Whenever you can read these equations, it makes sense to you. If you just look at it as D equal T again, you don't know what to say. We need to know that this means the value of D is the same as the value of time. Value mean the numeral, the
Value
number
of
to get the distance, and the same number of the time. You guys follow me?
Mm-hmm.
Okay. Is this true for this? Is this true for this here? Is the value of D the same as the value of time?
No.
No, sir.
No. So then our next step, Francis, Xavier, Shane, everybody, is we have to ask ourselves, what must we do mathematically to distance to get time? Or what do we do to time to get distance? So let's go this way. What do we do mathematically to distance to get time?
Add 2 to it.
To distance?
No, time.
Okay, so you add 2 to, so time plus 2
Time plus 2.
is the same as distance.
D.
You guys follow what I'm saying? What's going on here?
Yup.
You guys seen here?
Yes, sir.
So you just add a 2 to the time, which is
Time.
23 seconds,
Right.
which made it to 20.
25. And it works for everything, don't?
Yes, sir.
Good. So the equation must work for everything, or it is not correct. Am I clear?
Yup.
Clear?
Yes, sir.
All right, now we can write this same equation a different way. We can now ask ourselves, what can we do to distance to get time? Talk to me. Xavier,
Repeat what you said.
what do you do to distance to get time?
Subtract 2.
What do you do?
Subtract 2.
Subtract 2. So distance subtract 2 would give you time. Is it getting clearer to you guys now?
Yes, sir.
So when we read this, we have to read it as saying the value of distance minus 2 will give us the value of time.
Time.
Okay? And once you read, this is the correct way. There's no other way to read the equation. All right. There's no other way to read an equation. This is it. Why am I failing? All right, guys. Can anyone do the other one for me? This one.
Sir, let them mute.
Add 4.
To what?
Add 4 to the whole time.
8 plus 4.
Say again.
Add 4 to the distance to get the whole time.
10 plus
What?
same distance plus 4, same as whole size. Is that what you guys
And
have?
subtract 4 from whole time.
Is that what you guys got there?
Yes.
Breaking up, sir. I didn't hear.
Yeah, I'm asking if that's what you have. I don't know why there's so much feedback going on. In the equation, H represents whole size. And you guys would realize that if you add 4 to distance, you get 29. If you had 4 to 300, you get 304. If you had 4 to 35, you get 39. All right? And that's where the equation came from. Are there any questions? Are there any questions? No. All right, let's do
No,
the last.
sir.
Let's do question. Did someone say yes? No? Okay. Let's do
No,
question.
sir.
Okay, good. Let's do question number 2 now. Let's roll.
Very low.
I'm low. I'm saying let's do question number 2.
So you're going to subtract
You're going to subtract what?
360 from 33.
From 33? How is
Yeah.
that so?
Because instead of pump, created
Pump
a whole
rifle.
size.
The pump rifle. A pump rifle here. Pump rifle. Let's start going with that about.
Created a whole size of 360 and it's asking you to find the time.
Okay. So, can you find the time from anything you have here?
Yeah.
What would you use?
Minus 360 from 33.
How did you get that?
Because they're replacing the whole size and subtracting it from the time to get the actual time.
How?
What you said?
What's the relationship there?
The relationship is
You have to have a relationship between all size and time.
327.
327? I'm not understanding how you get that. Are you just picking some arbitrary values? How you get the 33? I'm not understanding that.
The 33 that is in the table.
In the table? Where is it? Here?
Yes.
So are you saying that 33 seconds minus 360 give you the answer?
Yeah.
No, Jamelia. This 33 seconds is for a distance of 35. The whole size is 39. So if your whole size is 360, it couldn't be 33 when 33 seconds is equivalent to a 39 centimeter squared whole size. You follow me?
Yes, sir.
Okay. So guys, this is where your equation skills come into play in mathematics. Now, you have 2 critical equations here. So, one up at top, one down at bottom. You guys ready for me? Our objective here is to find the time. So in this problem, you're going to have to ask yourselves, if you're trying to find time as your missing variable here, time is equal to unknown, then you have to ask yourselves, do you know any relationship between time and the whole size? And you said no. But what else do we know? We know that if you have whole size, you can find distance. And if you have distance, you can find time. You guys follow me? Thumbs up if you're following me.
Yes.
Thumbs up if you're following me. Answer me if you're following me.
It says distance to find time.
So yes. So there's a relationship up here between distance and whole size. So we use the whole size to find the distance and then use the distance to find the time.
Find the time.
You get me? You with me?
Yes, sir.
And this is called reasoning because we know there's a relation. So far, good to go?
Yes, sir.
So we know there's a relationship between distance and whole size, so we can use that. And then we know that there's also a relationship between distance and time. So once I have time, I have distance, sorry, I can use the value of distance and find time. So you guys try that for me. Try to use your whole size and find distance, then use the distance and find time and tell me what you get. Try that for me, please. 10 seconds to complete. Finish? All right, ready, everybody? Trisha? Xavier? Xavier, I'm starting with you. What did you get as your answer? Xavier? Xavier?
So I'm not sure if me have right still now. But
Go ahead.
I'm good still.
First time you do it in your life, right, Shane? So you have to take a time and build a confidence. Good?
Alright.
What did you get? What did you get as your answer?
We use the distance to find the whole size, right?
You use the whole size to find the distance.
Find the distance.
Right.
So what me have is D equals H minus 60.
Minus what?
60.
No, Shane, you're not open. See relationship here, Shane? Don't invent your own relationship. See there, Shane? D equal H minus 4. Let's say go.
Yeah.
So
D
what
equals
is
H.
okay? Francis? Jamelia? What they gone mute by me? All right, Shane, I'm here alone. Yes, Shane. So Shane, when you put in your 360, what do you get? And subtract 4, what do you get?
What, 360 subtract 4?
Right, because your whole size, see there? Your whole size is 360, right?
Yes, sir.
Subtract 4, what do you get?
356.
Okay, so that is your distance, right?
Yes, sir.
Now based on the equation over here, so you can, if you know your distance, you can find your time, don't? So time is the same as distance minus what?
What, 4?
No, man, look on the equation, man. Nobody guess nothing. No
Minus 2. E
2.
minus 2.
So you put in your 356 minus 2, where you get?
354.
Okay, good. That is your time. Okay?
So the time is 354?
Seconds.
Yeah.
All right. Let's see what's going on now. Trisha, Xavier, Francis, Jamelia, talk to me. What's going on?
Huh?
What's going on? You guys following?
Yes, sir.
Okay. Xavier, you gone? Shane, Francis, Jamelia.
I'm here, sir.
Here. You guys following what's going on here?
Yeah.
Okay, so right in this question, we had the whole size. That's all we knew, but we are trying to find time, okay? We knew that if there's a relationship established between distance and whole size, and so if we have our whole size, we can use it to find our distance. then we also know that if we know the distance, we can use that value to find the value of our time. And we'll answer the question. Okay, guys? You guys clear?
Yes, sir.
It gets better with practice. So let's roll. I'm going to take this off the screen right now. Here goes your next question. All right, guys, try this for me, please. Xavier, are you with us? Deshaun, I hear much from night, you know. Deshaun, you good?
Yes, sir. Just the Wi-Fi chopping
Okay.
and coming up.
But you're good to go, though.
Yes, sir.
Okay. Jamelia? Jamelia,
Yes, sir.
are you good to go?
With this,
Yep.
I guess.
You guess? No, man, you never guess. You must know if you're good to go.
Huh?
You must know if you're good to go. Xavier?
Oh yeah. Oh yeah.
Xavier? Xavier? Francis? Trisha. Where is everybody? All right, guys, I'm ready now. Ready to go? All right, so based on the question here, the question said that the following points were observed. 3, 6. X is 3, y is 6. 2, x is 2, y is 4. X is 4, y is 8. Write an equation to show the relationship between x and y. Okay. Jamelia, what would I start with?
X equal X is that.
Start with x.
Same as Y.
Same as y. Okay. All right. Is this true, everybody? Is x the same as y? Is the value of x the same as the value of y here, people? Take a look. No, this is 3, this is 6. This is 2, this is 4. This is 4, this is 8. Yeah. Good. So now our next step is to do what? What's the next step here?
You to make x equal the same as y, you have to add 3, and to make y the same as x, you have to minus 3.
Okay, and that works for everything? Let's try that, Jamelia. If you say
not for everything.
Oh, it has to work for everything. It's one equation that works for everything. Think again.
2, but 2 cannot go into 3.
There, somebody says, Trisha, you were saying something?
No, it's wrong.
Come on, think mathematically. Ask yourself, what can you do to x to get y? And it must work for everything.
Could it be divided
Times it by 2.
You're Shane with the answer there? You're Shane with the answer there? Times what by 2,
times
Shane?
By 2.
Times what by 2?
3.
Times
3 times 2.
In an equation form, what would you be saying that you're timesing by 2?
Oh, 3 times 2x.
No, sir.
No, man, 3 times 2.
Which is what?
We'll give
So
3 times 2.
In the equation, what do I write?
X times equal.
Isn't that 2 times x?
No.
2x?
Yeah, 2x.
2x equal to?
Y.
Y. Everybody see that?
Yes, sir.
Yes, sir.
So because if you multiply this x by 2, you get the y. If you multiply this
4.
X by 2, you get the y. Everybody see that?
Y.
Okay. Now, what must you do to y to get x?
Minus. No. Hold on.
Yeah. Think again.
Divide.
Divide what?
6 divided by 2.
Is it 6?
I divide y by 2.
Okay, so x is the same as y divided
by 2. Y over 2.
Excellent. Everybody see that? Xavier, Trisha, Francis, Jamelia. It will come to you, you know. This is really the root of equations. You shouldn't have been doing any equations in your school, day school, evening school, whichever school, unless you learn this from day one. Because this is the basics of every equation you got. So once you can manipulate equations from here, then I suppose we can manipulate it anywhere else. Okay? Alright, let's read this question. It says, if the value of x is 15, what is the value of y which corresponds? Anybody? Answer? Somebody's supposed to look on it and tell me the answer.
Of x equals 15.
What's the value of y? Who get 30? Xavier?
Yeah.
Good job, Xavier. Because we said the relationship is y is the same as 2 times x. So if x is 15, 2 times 15 will give us y. Okay? So it's 2 times 15.
Oh,
Yes, Shane. Yes. Yes, Shane. Equal
so,
to. Yes, Shane?
so whenever you distinguish the first question, they use the same formula to answer the second one.
Right, because that is this appears to give it to the relationship between x and y. All right, Shane? Which
Yes,
means
sir.
once you know the relationship, you can just and you have the relationship, you can use it to find a unknown. All right?
That opposing still.
Yeah, man.
Yes, sir.
To go. So Shane, whose phone is that?
Yes, sir.
All right, so Shane, this is how I knew you. Everybody don't understand even the simple interest and those things when I do. But no one understand. I know. I'm a master at this game, so I know what's going on. Cause if you did understand the simple interest and all of that, when you see this, you must know say if me give one value and you have the relationship, you can just put in the value and get the answer, don't?
Sir, but me not look at it that way. Me not pray that way then.
Alright, that is why you have to look at maths on a holistic view. Alright, Shane?
Me not pray that way then, but just know me realize everything connected.
Excellent. Every single thing is connected. There's no box in a maths. Everything connected as one. Alright, Shane, everybody?
Yes, sir.
Okay. Alright, here goes your next question. Oh God. Where are we at? Let's see who's going to finish the quickest on this one. Anybody finish? Remember, you have to think about mathematics. What you can do to this, and it doesn't necessarily mean one thing. You can add and multiply, you can subtract and multiply, you can divide and subtract, whatever you must do to get the answer. That's what we're looking for. Guys, ready? Let's go. Let's go. Xavier, I'm starting with you, Xavier. What's that? What do you have on your mind?
X equal to Y.
So what must you do?
Oh,
gosh.
whoa.
Well, I'm gonna wait, Xavier. Jamelia, what's your equation? Jamelia. Jamelia. Shane. Francis. Dushan. Trisha.
Sir?
What's your equation?
Sir, them it's all of them try wrong. I guess I still not get it.
You know get the equation yet? Don't worry, man. We're actually stepping up to another level, so you might find this one more difficult. Okay?
Okay.
Yes,
Shane,
sir.
what's on your mind?
May I find out a different? Yes, so yeah,
I got the hang of it, but the numbers them because basically what you're trying to do is the two in the bracket equal, right?
In the bracket?
Yeah, the X and the Y, whichever.
You're trying to represent the equality between the two.
Right, but then the same number have to represent all three sets.
Right. Same equation have to represent all three. Yeah.
Can't figure out the number there.
All right. Anybody else want to try?
So I'm -2 from the first two. We get the same, and then when we reach the third one, we get different.
You know work. All right. So I can't eat that. At least you're trying. It's good to try. You fail. When I show you, you will like, oh, that.
But the concept is right though, sir, right?
Yeah, man, your concept is so correct. And that's important. The concept is what is important. All right, let's roll. Everybody ready for me now? Since nobody no want to try. Look at it. Yeah. What do I do to X to get Y? I multiply X by 2, and then I add, drum roll. 1.
1.
What kind of thing?
2, 3, 6 plus 1. Seriously?
Seriously.
2, 5, 10 plus 1, 11. Oh my God.
Wait for the drum roll, man. Wait for the drum roll.
Oh, Lord. Okay, so that's
Sir, what kind of thing that?
That's how you go.
you understand?
Yeah.
Everybody ready? So now it says, if the value of x is 15, what is the value of y? So you want to know.
So it's 2x times 15 plus 1. 6 2x times 15 plus 1. So I don't finish.
What's the answer?
31.
31.
Yeah.
Y equal 31.
Oh, yeah.
So the value of y is 31. Everybody good?
Just like it's interesting now. All right, you can give one next one.
Back foot. All right. Here comes another killer now. Ready?
Seriously. No, sir.
All right, there you go.
I'm not seeing.
All right, there you go.
You can bring it across some more.
Some more. So
Yeah.
so the first one is x and the second one is y, right? So.
All
right, good.
Oh, that's not lovely. -5. Just have to feel like I understand.
That's how you go, man. You know, see, learning is not linear, you know. It's straight, you know. You take your time and your brain wrap around it and wrap around it. Because what this telling me, Trisha, is that just like Shane, all of what you were doing before in consumer arithmetic, you never understand nothing. That's all it tell me. No, sir. You think you understand. You were following, but you don't understand. So you knew how to regurgitate it, but you never did understand. But that's okay. Anybody got it yet? I'm already know. By now, I'm supposed to get the first one. By now, I'm supposed to get the first one. Are we ready, guys? Shane, Francis, Trisha, Deshaun, ready? Ready? Shane, how do we start?
X equal Y.
Okay. You always start with your X, depending on the variable you have, but in this case, it's always X. It's X and Y, right?
X, Y, yes, sir.
Okay. I know we can put Y then Y equal X, but I same story, right? Okay. Now, is this true? Is X the same as Y?
No.
So our next step then is to do what?
Find what would make them equal.
Them equal by asking yourself, what you do to X to get Y, or what you do to Y to get
X.
Okay. X. Now, what is your guys? What's your answers? We're not going to drop dead. We're not see that one. Negative number kill you know. I know.
Go ahead, answer it. Come to Sean. May I have to answer that one?
Come on, guys.
So I want to get anything here from.
What? Okay, guys.
A negative.
What do you do to X? Right, what would it, look on them two here. Look on them two here. What do you think we do to X to get Y? We multiply X by 3.
3, I add 1.
All right. Come like it was jump out nation a while ago. I add 1,
yes.
So 3.
Me do it that way then, but me never get the relationship. One of them, so that's why I say it no work out.
It works. 3 times negative 2 is negative 6.
Yeah.
Negative 6 plus 1 is negative 5.
Yeah.
Do I go on? Okay. Francis?
Yes, sir.
You good to go?
Yes.
Francis?
Yes.
Are you understanding? Francis?
Yes.
You're understanding this?
Yes, I'm understanding.
Okay, good. All right, so, or we could write this another way, don't? What do we do to Y to get X?
Take away 10.
Take away how many?
Yeah.
Y is equal to what?
Y is equal to...
Sorry. X, I mean X. X, go on, say. X. How do we get X? Isn't X the same as Y take away 1 all divided by 3? Check it out. Shane, Trisha, Francis, check it out.
Yes, sir, sorry.
Right. So you just have to ask yourself, what must I do to X to get Y? Or what must I do to Y to get X? Mathematically. And it must work for every single thing you have. Okay, guys?
Yes, sir.
All right, the last part of the question. If the value of X is 20 and 36, what is the value of Y, which corresponds?
What?
20.
Got the answers?
No, sir.
When x is 20, what is y?
3.
It's 3
So
times
you're going
20.
to times it by 3 plus 1?
Yes,
Yeah.
61.
61. What can I want? 61. And when x is 36, what is y?
109.
Okay, whatever that again. Good. So that's the answer. All right, guys?
That's 2 separate answers there.
Yes, it's 2 separate answers.
So, hold on, though. Go back. Repeat this, brother.
All right, we said x, in this case, x has 2 values. X
Yes,
can
sir.
take the value of 20
and 36.
and 36. Because remember saying that it's a variable, so the value can vary, right?
Mm-hmm.
So when x have a value of 20, what is y? So in this case, 20 times 3 plus 1 will give us 31, 61, right? 61. And when x is 36, y has a value of?
Yeah.
36 times 3. 36 times 3 is what? 60, 70, 80, 90, 100. 109. Plus 1?
No, plus 1.
109. Yes, sir.
So 109. Okay?
Sir, one more thing before you stop.
Yeah.
Run back for that 3 times x plus 1 something business here.
Running back home, we get this? Because we look on it and we say, what we do for x to get y? And we realize that when we multiply the x then by 3 and then add 1, that gives us the value of y. Okay? And it works for everything. Okay?
It worked for the front one too?
Yeah, man. Because 3 times negative 2 give us negative 6. And then negative 6 plus 1 give us negative 5. So negative 6 means you owe 6 and then somebody give you 1. So you have to pay back 1 out of what you owe. So you know you owe 5. Okay?
Okay.
All right. Very good?
Yeah, I guess so.
All right, let's wrap up. This. Some people got.
No, give him back the border, please. Write it down. Finish writing now.
Okay. So Shane, what did you learn today?
Someone never know. Hopefully that one here.
Overwrite equations?
Yeah.
Yeah. So you realize, Shane, every single equation that you have used, now you know where them come from. They come from patterns, right?
Yes, sir.
So them observe some pattern and say, well, it look like, say, if I want to find this, I have to do this. So if I want to find simple interest equal P times R
times R times T.
Times T divided by
over 100. Oh yeah, divided by 100.
Over time, them realize, say, every time them try to find a simple interest, that's all them have to do. So you know, if you go through the long process of figuring out all the time, they realize that once you're finding a simple interest, just do that.
Interest, they use that formula.
They use that formula, which is called an equation. Okay?
Equation. Yes, sir.
It shows the equality between interest and everything else.
Yes, sir.
If you're doing, no matter what, if you realize in mathematics, every corner you turn equation make a joke you. So you have to understand equations. You have to understand how to read them. You have to understand how to derive them, mean how to write them. So when you understand how to write them, when you see them, you actually know what they're saying to you. Okay, guys?
Okay.
Yes, sir.
And this is where it is important. So if you see one formula, if me say, let me test one of you see. Trisha, can I clear this?
Yeah.
Okay. If I say area equal QP divided by 2. Okay? And I say Q equal 3 and P equal 2. What is the area? What's the area? Huh?
3 plus 2 divided by 2.
So I get, no, not 3 plus 2, I multiply the shade.
Multiply.
Yeah, multiply,
So 3
times
2
6
equals 6 divided by 2.
3.
3. Excellent.
3.
So again, this is just a relationship. You see the gist? Once you know the relationship, just plug in the values and get the unknown. All right? And
So then thing are you compound CSEC paper?
Huh?
Question like the compound CSEC paper?
Oh yes. You ever realize there's a question that is called a pattern question? Question 7. Or pattern question. Question 7. Or if you look at, can recall? Or if you look at question 7 is every year there's a question 7. You get a pattern to write, and with your pattern, you have to find the equation of the nth term and those things. That's every single year up on the paper. Then your next, every other question though on the paper have an equation. So the important thing here, Shane and Trisha and Francis, is that when you know where equations come from, when you see them, you know what to do. Okay? And you get something. You have to learn about area. You have to learn about, and you have a whole lot of different shapes. You have so many different things to deal with. And so when you see the equation area equal that, you know exactly. Say, oh, does that tell me? Say, if I want to find area, just put that in, do that, and get the answer. You get me? All right. So this is where this will come from. So every single year you will see equations right across the paper. But if you don't understand them, then you will not know what to do. Okay? Trisha?
Yes, sir.
What did you learn?
What
did you learn, if anything at all?
Equation is always on the paper. I learned that for those equations, you always start with an equal sign. Wait up it there again. And then when you're working out the points observed, you have to make sure that x is equal to y, and whichever number or what equation or that word, whatever you get there, it have to go right across the board.
Right across the board.
Good. So it must work with all the sets.
All of the points that you get. Are all the variables you are talking, all of the different examples or illustrations that you have, it must work for it.
And another thing, that it doesn't. The trick question. What happened? Not all the time. It's like just times or take away or whatever. You can use 2. Yeah.
No, that's the thing too. You can always post it, because you can't only use multiplication and division. You have to try use all of them and see which one of them is more suitable. So you can't just rely on any one of them. You have to just use it.
Right.
Yeah, but the other interesting part to it is like the part where you say you times the 2 and then you plus the 1. So you did you use 2 different
times. Where that come from?
In the same thing. So yeah.
Good night.
So that's kind of interesting because all I was there, I was like, 2 times that it just now work, divide it now work. Never know so you could actually add another part to it.
Add one to it. Yes.
Yeah. Well, you know, always have to be one, right?
No, man, it must be one. It can be anything.
I'm not sure.
Yeah.
Yes, Shane, it can be anything.
No, so it can be anything.
Where does I use one? So it's just
Okay.
because again, all right, Shane, how do you find the area of a square, Shane?
Area of a square.
Uh-huh.
Length times width.
Length times length or length times width. So area of a square is equal to length squared, don't
Yeah.
Okay.
Length times width.
So Shane, where did they get this from?
The what? The L.
The form, the equation. Where did they get it from?
Else.
Yeah. How do you think they got this? Where do you think it come from?
Boy,
them look.
Then just then make it much easier and see what and what would I give the whole area of it.
Relationship. Them look one couple square and realize say every time they get a square, the area of the square is always the same as length multiplied by length. Get me?
Yes, sir.
Forget about width, but me and I argue about the width argument tonight. Right? But them
say
always,
just length times length.
Yes, man.
Length square.
Every single distance is length. Says length squared. Alright? So them realize say no matter which square they got, once they multiply this side times this side, then get the value of the area. And so then decide say, oh, well, to make life easier for every pitney, here we go on. We can safely say that no matter which square it be, once more I find the area, we just square the length of one side and we get the area. You guys clear?
Yeah. I could have did that way there still.
Yeah, man. I will bad things they can learn that, man. But every single thing that they had.
So them just square the lengths and you get the whole area.
Hey, because remember length times length, right?
Because at the same time, and they're the same size, so.
Right. So it's
one side of that, the other side are gonna be that.
So this if
and
it's a square 2.
Yeah.
And 2 times 2 is 2 squared, right?
Yes, sir.
Okay. So that is from that pattern. From the pattern they shade. They say, oh, so no matter which square me got, if we want to find the area, we just multiply it one side by the other side. And we get the area. Cool? And for it, so guys, I know this is a longer session than all, but for every single equation we want to look on in a chemistry, in a physics, in a biology, every equation is derived from a pattern. Okay?
Yes, sir.
Then observe the pattern and just make a conclusion and say, well, if this will work for the next 100 things, we look the same, have the same properties. This must be true for all things. Okay? And they make life easier for you. They could make life complicated for you by having you going through what we just do a while ago. All right? But sometimes you have to do it from scratch for yourself. Okay?
Yes, sir.
Anything else, guys? Francis, what did you learn? Francis? Or Francis?
Hearing me?
Yep.
I heard that equation. To know equation, and that doing an equation and one equation has to be for everything in that specific category. Yeah, that's just that.
Okay. All right, guys. So just remember, people, the video for the classes are available online at some point in time where you can go back and watch them. But I myself or Christina has to give you access to them, and you can go back and watch them. All right. Until then, see you guys next time. Have fun. Remember that Thursday you have class with Shanique, so you don't come back here. Go back to Shanique. Have a nice day.
Okay.
Yeah.